Hello, my amazing students. We are doing 8.6, and I am right now trying to get these done anywhere I can, and I am in my husband's science room trying to get these last things on because you have a test on Thursday on this material. So you have 2 more nights to study it if I get it on today, which is what I want to do. Okay, so direct variation. We're talking about in 8.6. We're talking about variation, direct variation, inverse variation, joint, and combined. Okay, so we're going to have some examples of each one. The first one we're going to do is direct variation, and this is our equation. Y is equal to k times x. Direct variation keeps everything in the numerator, and if k is positive, as x goes up, y also goes up. If x goes down, y goes down. So a good example of direct variation is something like gas and distance, or time and distance. Okay, time and distance. So if I were going to say distance is rate times time, which it is, that is a direct variation, because if I am going a certain constant speed, like 60 miles an hour, and I travel for 2 hours, you know exactly the distance I will travel is going to be 120. So if I travel for 3 hours at 60 miles an hour, I'm going to travel 180 miles towards my destination. So in all of these variation problems, we have 4 steps, okay? So the first step is going to be to write the given equation the way it is described to us. The second step will be to find the k. The third step will be to re-express the equation with the k in it, and the last will be to answer a question, okay? So no matter whether we're talking about direct, inverse, joint, or combined, we will always follow these 4 steps. Okay, so it says suppose y varies directly as x. So I'm going to use the same equation I have up here. Y is kx. Now it says if y is 12 when x is 4, then, so if y is 12 when x is 4, then I've got 4k is 12, divide both sides by 4, and I get k is 3. So I find my k with the information they give me, okay? Then I re-express my original equation with the new k in it. So this little step is y is 3k. Since I found that k was 3, I'm going to substitute the 3 for the k, not the x. Okay, so y is kx, y is 3x. I substitute the 3 in for the k. And then lastly, I answer a question. Find y when x is -5. So y is 3 times -5 or -15. Okay, so these are pretty simple after all the ones that you've done in Chapter 8. They finish up with probably the simplest section that we've had for a while, and so that's a nice little break for you. Okay, so let's look at the next one, and I want you to think of the 4 steps that we're going to follow. Okay, we're going to find our equation, we're going to find our k, we're going to substitute our k in, we're going to answer a question. Okay, so this is our problem here. And it says, suppose p varies directly as the root of z. So p varies directly as the root of z. Now if it just says root, and it doesn't say square root or cube root or fourth root, we always assume it means the square root. That's our default there. So p varies directly as the root of z. If p is 20 when z is 25. If p is 20 when z is 25, So I fill into my equation here those that they gave me, those little facts they gave me. And then the square root of 25 is 5. So I wind up with 20 is 5k, or k is 4. So I have solved for k. K is 4. So now the third step is to take the k and put it back into my original equation. So that is going to be p is 4 times the square root of z. And lastly, I use my new equation to answer a question. And the question was, find p when z is 36. So p is 4, and then I'm going to substitute in z is 36. The square root of 36 is 6 times 4, so p would be 24. Not much to it, is there? Remember your 4 steps, they work no matter which type of variation we are doing. All right, so now here is another one, and this one says varies directly. So a coffee shop's revenue varies directly as the number of cups sold. If the revenue from the sale of 305 cups is 549, find the revenue from the sale of 400 cups. So this one is pretty straightforward, but it was a lot of words to copy down. You've got to give me that. Okay, so our 4 steps is first, since it is just a simple direct variation, I'm going to say revenue is some k times cups. Okay, so that's going to be my equation. And then I'm going to put in the information they give us. So they said if the revenue from the sale of 305 cups, so I'm going to put 305 where cups was, is 549, so I'm going to put 549 where the revenue is. So here's my little equation here that I'm going to have to simplify. Then I am going to say k is 549 divided by 305. 549 divided by 305. Now, I should be able to simplify that. Let's see, 500, I'm going to just do the math over here because my calculator is on my phone, which is videoing me. So that's going to go 1 time 305, 4, 4, 1. And so we're going to do maybe maybe 0.4. Let's check 4. 4 times 0 is 5. 4 times 0, 20. And then 4 times 0 is 4 plus 2. And then 4 times 12. So maybe 4 or 5. Okay, so I'm going to leave it like this because this is not coming out real beautifully. So I'm going to leave my, maybe it divides, but I'm not finding it right now. So I got 1.5, 1.4, somewhere in there. So I'm going to go ahead and just leave the k like this. So my new equation is revenue is k, so that's 549 over 305 times c. So I'm just plugging it in, okay, because I don't have my calculator. I'm not reducing it right now. And the last thing is to answer the question, okay? Then what would be the revenue from 400 cups? So now I get revenue is 549 over 305 times 400. Okay, so now when I crank that all up, then I should get, I have the answer in here, so I give you the answer even though I don't have my calculator right now to figure it out. And my answer is coming as soon as I look up the answer. Get your calculator and figure it out while you're waiting on me. Okay, 549 divided by 305. And we should get, I have too many pages here, $720. Okay, $720. So hopefully if you multiply all that out, you're going to get $720. We could cancel this one with this one, cancel out the 5s, but we would have to multiply. Okay? So that's the process, and that should be the answer there. Okay, so now we're going to do a little bit with inverse variation. So here's an inverse variation equation. Y varies inversely as x. The x must go downstairs. So now it says, suppose that q varies inversely as h. So my first little thing is write the equation. Q varies inversely as h, so h has to go downstairs. Okay, as if q is 9 when h is 10, yes, if q is 9 when h is 10, they erased here. Okay, so if q is 9 when h is 10, then if I cross multiply, my k is 90. K is 90. So I find my k, and then it says my next step is to rewrite my equation. So that's going to be q is k over h, but k is 90, so q is 90 over h. Okay, and then the last step here is to then find q when h is 15. So if h is 15, 90 divided by 15 is 6, so q is 6. That was an inverse variation, and we solve it just the same way, but we have the formula here where the variable goes downstairs. Okay, so now this is a huge joint variation problem that I'm going to read to you. It says the force exerted on an object varies jointly as the mass and the acceleration of the object. If a 60 Newton force is exerted on an object of mass 10 kilograms and an acceleration of 6 meters per second squared, how much force is exerted on a 12 kilogram object with acceleration of 4 meters per second squared? Okay, so we're going to find a board that we can erase and do this problem, and then I'll come back with just a couple more to finish up. Okay, so basically it says the force extended on an object varies jointly as the mass and the acceleration of the object. So we're going to have force varies jointly with mass and acceleration. Okay, so anytime you have a joint variation, you're going to assume everything is direct. So now we just have two variables with a k. Okay, force varies jointly, so we assume directly with mass and acceleration. So then, after we write our equation, step 2 was to use the information they give us to find the k. So they say if a 60 Newton force, so the force is 60, is exerted on an object of mass 10 kilograms, so the mass is 10 kilograms, and an acceleration of 6 meters per second squared, then can we solve for our k? So they have 60 over here and they have 60 over there, so k is 1. Okay, so now step 3 is to rewrite the original equation with the new k. So force is 1 times mass times acceleration, but since it's 1, I'm just going to erase the 1. Okay, so now I'm going to use the new equation and the new information. So then it says, then how much force is exerted on a 12 kilogram object with an acceleration of 4 meters per second squared? So a 12 kilogram object with a acceleration of 4, and so the force on that one would be 48. Okay, 48 newtons should be the answer there. So I'm going to check that answer real quickly because I do have the answers here, but I'm going to use both hands because that's what took me so long last time, is that I could not flip through and look and see if we had the correct answers. And the answer to that one is 48. Okay, and I'm going to be back with just a couple more problems. All right, so we're going to have 2 more problems. One is going to be a joint variation. One is going to be a combined variation. Okay, so this first one says, suppose that t varies directly as the square of r and inversely as q. So this problem is a combined problem. It is a combined variation because it is involving direct and inverse variation. Okay, if t is 9/2 when r is 3 and q is 16, then find t when r is 5 and q is 10. So first we have to write our equation, find our k, rewrite our equation, and solve the question. Okay, so it says suppose t varies, we got to have a k, directly is the square of r, so we got r squared, and inversely as q. So we should have k r squared over q is our equation. If t is 9/2, so we plug in 9/2, when r is 3, so we have a 3 squared, and q is 16, so that should be my equation. And now I have to solve that equation for k. All right, so this is a 9. 9 squared, 3 squared is 9. Now notice I have a 9 in the numerator and a 9 in the numerator. I'm just going to get rid of those 2 9s because they're in each one of the numerators. So now if I cross multiply, I get 2k is 16, k is 8. So now I'm going to put k is 8 back into the original formula. So then I'm going to have t is 8r squared over q as my new equation. And then it says find t when r is 5 and q is 10. So find t when r is 5, so I have a 5 squared, and q is 10. So I end up with 25 times 8 over 10, and that winds up being 4/5 of 25, which is 20. Okay, so t should be 20 on that one, and that is the correct answer. So I'll show you the whole big thing there so you can take notes on that. And the last problem on variation. This one is a joint variation. The last one was a combined variation. Joint variations are assumed to be all upstairs, all direct variation. Suppose r varies jointly as s and t. So our equation is going to be r varies jointly as s and t. And then it says if r is 120, when, I need a little bit more room here. If r is 120, when s is 5 and t is 4, so then I have 20 times k is 120, and that means that k would be 6. So then once I find that K is 6, I'm going to go and rewrite my equation here with a 6. So I'm going to have R is 6ST. So now, last step, answer the question. Find R when S is 3 and T is 7. S is 3, T is 7, and my constant was 6. So R is going to be 21 times 6, which is going to be 126. And that is the correct answer. And there is your board, as large as I can get it. And this is Mrs. A, and may God bless your day.